Right, so in this video I'm going to have a look at question 7 from the Maths Higher Level Paper 1. Now question 7, the first part of it, involves a spherical exercise ball which is being pumped with air at a rate of 250 cubic centimeters per second. So let me write that down. Being pumped with air at a rate of, so that's going to be dV dt. The volume is changing with respect to time at a rate of 250 cubic centimeters per second. Find the rate at which the radius is increasing. That's dr dt. The radius is increasing at a rate. So we want to find that out. What else can we write down? Well, we know that the volume of a sphere is going to be 4 over 3 pi r cubed, and we can differentiate that. So dV dr is going to be 4 pi r squared. So let's see, let's write down an equation anyway with all of this in it. We need to find dr dt. So let's write that down. We need to find dr dt. So that's going to be, well, we have dV dt. So let's write that down. We don't need dV at all, so let's put that down at the bottom here. And we need a dr on the top here, so dr dV here. So let's see, will this work? We need to find dr dt. dV dt we have, that's here. Dr dV we don't have, but we have dV dr. So dV dr is this here, so that means dr dV, you just flip it upside down, will give us 4 pi r squared, 1 over 4 pi r squared here. So we have everything here on the right hand side, so let's just stick everything in and see what we end up with. Well, dV dt is 250, dr dV we've just worked out is 1 over 4 pi r squared, so that's fine, and 250 divided by 4 will give us 62.5, and that's over pi r squared. Okay, so this is radius, which is centimeters, and it's the rate of change of the radius with respect to time, so that's centimeters per second. Now, we were asked here to find what this rate is when r is 20. So when r is equal to 20 centimeters is what we want to work out. This gives us a dr dt of 62.5 divided by pi, and we want the 20 here squared. When you work that out, you get 5 over 32 pi, and this is centimeters per second. So we were asked for our answer in terms of pi, so this is our answer here. Okay, perfect. So let's move on to the next question then. The next question asks us to find the rate at which the surface area of the ball is increasing when the radius is 20 centimeters. Okay, so let's write down, I'm just going to write this down again here, our dr dt, we're probably going to use that. Dr dt we worked out is 62.5 over pi times r squared. Now we need to find the rate at which the surface area, that's ds dt, s is surface area here in this case, that's what we need to find out. Now what can we do? Well, the surface area of a sphere is 4 pi r squared. So if we differentiate that, we get ds dr. Differentiate s with respect to r here, that will give me 8 pi. 2 4 is 8 pi, yeah, reduce the power by, 8 pi r, I should say. Bring down to 2 multiplied by 4 gives me 8. Reduce the power by 1, so there's 1 here, that's fine, yeah, 8 pi r. Okay, fine, so let's just write down our equation again, same as the first time. So we want to find ds dt. So we want to find ds dt. So let's see, what have we got? Well, we have dr dt, so that gives us our dt on the bottom here. Now we don't want a dr here in our answer, so let's put a dr on the bottom here. And we want a ds on the top, which we don't have yet. So let's see, do we have these? Well, dr dt, we have that. There it is there. ds dr we've just worked out here, so we have that as well. So we have everything. So let's just stick this in. Dr dt is 62.5 over pi r squared. ds dr is 8 times pi times r. Okay, so that's fine. The pi's here will divide, so that's fine. So we end up with 62.5 times 8. So let me just work that out. 62.5 times 8. That gives me 500. So that gives me 500 on the top here. And we have pi's which cancel. The or will cancel with one of these. So that's just divided by or on the bottom here. Now, let's see, we also have, let's see, 8 pi or, we have a pi or squared, so that or will cancel with that or there, that cancels that, so that's 500. Yeah, so we want to divide that by 20, because remember we were told that the radius, this is our rate of change of surface area with respect to time, so surface area is centimeters squared per second. So this is our answer here. However, we're told that the radius is equal to 20 centimeters. Okay, the radius is equal to 20 centimeters. That means ds dt is going to be equal to 500 over 20. So that gives us 25 centimeters squared per second. Okay, so that's that one done. Let's move on to the next one then. So in this case, the inflated ball is kicked into the air from a point O on the ground, taking O as the origin, and we have x's and f of x. Approximately describes the path followed by the ball in the air, where f of x is minus x squared plus 10x, and both x and f of x are measured in meters. Find the value of x when the ball is on the ground. Well, when the ball is on the ground, f of x, when the ball is on the ground, let me see, the height here is going to be 0. So the height here is given by f of x. So we're going to take 0 is equal to minus x squared plus 10x. I'm going to work out what x is here then, so we would, this is just simply factorizing here. Well, what we can do here first of all actually is just get rid of this minus here. So multiply across by minus 1, so that'll give us x squared minus 10x. Now we can factorize here, so we've got 0 here is equal to x and x minus 10, so that will give me x is equal to 0 or 10. Okay, so these are our two values for x. Now, let's just have a look at the next one then. Find the average height of the ball above the ground during the interval from when it is kicked until it hits the ground. So we want to find the average height. So really what we're going to do here is use our average value formula. It's an integration question. So we're going to take 1 over b minus a, the integral of f of x here, really, f of x dx. So our b and a here are going to be 10 minus 0. We're going to integrate from 0 to 10, and our function is minus x squared plus 10x, and we're going to differentiate with respect to x, or integrate I should say, with respect to x here. So let's do that. So that's going to give us 1 over 10, and we're going to integrate here, so that's going to give us, let's see, minus x cubed over 3 plus 10x squared over 2, and we're going to integrate from 0 to 10 here. Okay, so let's do that. So this will give us 1 over 10 times, okay, so we've got to put 10 in here first, so it's going to be minus, it's going to be 10 cubed over 3 plus, well, this is 10 divided by 2, that's going to be 5, and then we've got our 10 squared here. That's that bit there. Now we've got to subtract. Now if we put 0 in here and 0 in here, we'll just end up with 0. Okay, so let's do that. That will give me 1 over 10 times, that will give me minus 10 cubed, so that's going to be 10, 10, 10 over 3 plus 500. And this is just 0 here. So when you do that, then you're going to get an average value then of 16 and 2/3 meters high. That's our average. That's our average value of this particular function. Our average height of the ball above the ground. Okay, so that's it for this particular question. I'll do question 8 in another video.